we introduce to you something about preferences. And we may use indifference curves to capture the idea of preference. But actually preference is not an idea that is which is convenient to use. It's not convenient enough because we cannot apply math to this type of concept, preference. So economists come up with something we may just use directly with mathematics. So it's more convenient for us, which is utility. In difference curve, the translation is 微曲线. Utility, 效用, utility. So utility refers to a set of numerical values. There are values, numerical values, that may reflect the relative rankings of various bundles of goods. So from evaluating these bundles of goods with preferences, now we want to use another concept, we call it utility, to capture the insights, the nature of our preferences. So we just introduce utility, which is convenient, more convenient for us. And since utility are values, we may compare values with something like we are more familiar with, like x is greater than y, something like this. For example, 5 is greater than -1. Okay? So for real numbers, it's better for us. And utility function is the relationship between utility measures and every possible bundle of goods. So it's a function, utility function, which is utility is a function of bundles. X is a combination, so S can be hamburger and Coke, something like this. Okay? So you just input something, a bundle. You input a bundle, and the output of this function would be a real value, utility. So for points, for all points on the plan is a bundle of good, right? Any point on the plan is a bundle of good. And we just throw this bundle, these points, into the function, utility function. And then this function would give us a value, a utility level of this point. Is that clear? So for point A, we may have, sometimes we just use U, or U, big U or small letter U. So we will have correspond, using utility function, we may have U of A, and we may have U of B, and we may also have U of C, and U of D. Using a function, using the utility function, we may have the utility level of the point. The utility level of the point. And whenever we wanted to compare this point, we may directly say, oh, D is strictly preferred to C, and C is strictly preferred to B, and B is strictly preferred to A. We may also say the utility level of D is greater than the utility level of C, greater than the utility level of B, and the utility level of A. Is that clear? So its preference is real numbers, which means utility levels. And we may use these numbers to calculate or to compute, to satisfy something easier for us to compute or to apply mathematics, especially differentiation. Okay? So for example, Q1, if Q1, the variable on the horizontal axis, is pizza, and Q2, the variable on the vertical, is burritos. You know burritos? Burritos? Mexico burritos. Okay, pizza you know, okay? Burritos. So Q1 is the number of pizza, Q2 is the number of burritos. So bundle X contains 16 pizzas and 9 burritos, and we just input 16 and 9 is 144, right? And take the square root, we got 12. So the utility function value is 12. Is that clear? And if another bundle, Y, contains 13 pizzas and 13 burritos, and we got the utility level 13. Since 13 is higher, is greater than 12, then we may infer that Y, the bundle Y, is strictly preferred to bundle X. Okay? But you must notice that this is just an example of utility function. Not all utility functions look like this. Okay. Is that clear on the slide? And utility is an ordinal measure rather than a cardinal one. So the key is the order rather than the not the size, rather than the magnitude. So I would not say for example, if we got a utility function like equals like a function like this. So U12 equals 2 and U41 equals 4. And I would say the bundle for 1 is strictly preferred to bundle 1, 2. But I would not say the bundle for 1 gives us satisfaction twice of bundle 1, 2. I would not say, oh, it's twice of this. No. I would just say the rank, the order, this one is better. So the value, the point is, the key of these values are their order rather than the absolute level. Okay? So in this case, we may do something. So utility tells us the relative ranking of two things, but not how much more one rank is valued than another. So we don't really care whether they are, we don't really care about the numbers. We just care the rank of these numbers. Therefore, any utility function which generates this result would be consistent. What does it mean, consistent? So let me give you something. Okay, positive monotonic transformation. We may use this kind of transformation to generate millions of utility functions. Like if we have a utility function look like this, we may actually have another one like equals x squared y squared, and which is u of x and y, the square of u of x and y. So to take a square is a positive monotonic transformation, which means V12 equals 4 and V41 equals 16, right? The rank doesn't change, but the absolute value we don't care at all. Okay? So I would not say, oh, the utility level is twice of this one, but in this case it's 4 times of this one. We just don't care about the absolute value, the cardinal thing. We just care about the rank, the relative rank. The relative rank. So any kind of transformation, positive transformation, is good. Say, let me give you another function, x and y, which is utility, say, plus 5. Do you think this is a positive monotonic transformation? Which means the order remains, but the absolute value we don't care. Okay? So in this case, W12 equals 7, right? And W41 equals 9. Still, this bundle, the utility level of this bundle, gives us a higher one than the bundle 1, 2. So still, we prefer for 1 to 1, 2. This kind of utility function is fine. It's okay. It's adopted. Okay? So any utility function that's generated this result would be satisfied, would be consistent with the preferences. Okay? So either plus 5 or minus 4 or take a square root or something like that. Anything you can do. Take a square or a cubic is to the power of 3 to the power of 100. Anything you may do. So you just keep the order the same. Keep the order, but we just don't care about the value. Okay? Any transformation satisfying this kind of transformation is fine. So a utility function can be transformed into another utility function in such a way that preferences are maintained. I would like to invite you to do something like, if I give you a function h, k, m, for example, which is something transformed from u here. So I just gave you an example. V equals u squared is a positive monotonic transformation. And actually you may take the, okay, anyway, please try try your best to figure out 3 kind of transformation. I just give you some example here. Some examples is square or +5 or -4 or something. You try yourself. Alright, give me some example.
Square U.
Square. I just gave you square.
Log.
A log. Good. Log U. Or. Actually, mostly we use log. Don't call this long. It's log. It's a natural log. It's a natural log. And the base of this is actually the Euler number. Okay? So it is read as log, not long. Okay? Log is a natural log. Okay, so the log looks like this, right? So the transform of U into a log U is the higher keeps the higher, right? And the lower remains lower. So we call this as a positive monotonic transformation. The higher remains the higher, the lower remains the lower. Okay? The order just doesn't change. Another example here. Give me some example. +5. I gave you +5. Give me another one. Okay, just stretch. Anyone give me some example? Since you have a log, can we have an exponential thing? May we have exponential? Right? Or make it simpler, square root of U. They are all positive monotonic transformation. Okay? So you may have millions of utility functions capturing the same relation here. Is that clear? But we don't need that many, we just need one. Just need one. Alright, the general utility function, we call it now we have a 3D diagram here. It's a B, burrito, is Z, pizza, and it's U, pizza and burrito. So this is 0, no pizza, no burrito. So 0 gives us, for example, the level of utility 0. And you may see different points on the plane, on the pizza burrito plane may give us different or various values of satisfaction. Okay? So if we just use a plan to cut, and then we may cut the trace of indifference curve, right? Say, if we just raise the height to 2, and we just shoot, then this, the intersection, we may have a chase of points giving us the utility level of 2, right? So all these points since their utility level is the same, I should say are the same, then they locate on the same indifference curve, right? And if I raise the plane to like 3, there is another indifference curve, right? Is that clear? Another angle, pizza, burrito. This is another angle, so 2, 3, 4, 5, and difference in difference curve. Variance in difference curve. And pizza, burritos. If we use ZB, this specific utility function, then if I further ask you to restrict this function to the level of 4, if we just restrict this function equaling level of 4, then what happened? What do you think? Which points satisfy this relation? Of course, 2, 2, right? And 1, 4, or 4, 1. Anything else? Can I have a 3, 4, 3? 4 third, right? The multiple of these two numbers equals 4, right? And I can also have 100 like 0.4. Oh no, sorry. 0.04. Okay? So all these bundles satisfying the utility level of 4. Which means all these points are on the same what? Right, indifference curve. Is that clear? Okay. What about if we make it like 8? Can you figure out some points satisfying the level of 8? 1, 8, 2, 4, 4, 2, 8, 1. At least you may have 4 points here, right? 4 points here. And further, you may have something like 5, 8 over 5, something like this. Okay? All this infinite numbers of values can satisfy this condition, and all of them are on the same indifference curve. But this point, the indifference curve for these points locating on is different from the indifference curve of these points. Is that clear? Okay. So you just make a function. You make a function to a fixed number, either be it 4 or 8. You make a function equalize to a number, to a specific number. So we may capture the idea of indifference curve using this logic. So if I say, okay, U bar is a specific number. It's a number. It can be 4, can be 8, can be anything. But it's just a constant, is a number. U bar equals U of pizza and burrito. Okay? So this just describes an indifference curve. Once again, it is a utility function. It is a constant. When a utility function equals a constant, this represents an indifference curve. Is that clear? Just as the examples I gave you. Okay? Alright, then we may do something. Well, it's okay. Alright, let's do something here. Let me change the symbol to something we are more familiar with. Say Q1, Q2. Q1 on the horizontal, Q2 on the vertical. So we have two goods here, and the quantity of these two goods are Q1 and Q2. And now we want to take a total differentiation. How can we do that? What do you think the differential of U bar? What is it? What is this? What would it be? Or the difference of U bar. Since U bar is a what? Is a constant, so the difference of the constant would be zero. Very nice. So the differential must be a zero, right? Differential means the change of U bar. The change of U bar must be a zero because U bar is a constant. Is that clear? Okay? And the utility function. The utility function is affected by two things, Q1 or Q2. So, how does this utility affected by Q1? It would be partial U, partial Q1, right? So the reason why we apply partial is because we hold Q2 constant. We want Q2 unchanged so that we may evaluate the effect of the change in Q1 on the change in Q2. The change in U. Is that clear? So partial U, partial Q1 means an extra change or a 1 unit change in Q1. We want to know the effect of this on the utility level. And this is the marginal effect. So, what do you think du1 means? What does du1 means? What does it mean? If you just cannot figure out the differential of u1, you just think about the difference of u1. This means the change in u1, right? The change in u1. Oh, thank you very much, Q1. I made some mistake. Thank you. Appreciate it. dQ1 or delta difference of Q1, which means the change in Q1, right? So this is the change in Q1, and this is the effectiveness or the influence per unit of Q1. Okay, so it is the influence of per unit of change in Q1. if the change in Q1 is actually 5, then it's 5 times of the influence. Is that clear? Once again, this item is the influence of per unit change in Q1 on U.